Distinguished guests, colleagues, and partners, it's a great honor to engage with you today as we gather to explore the future of green growth and deepen cooperation between the Nordic region and Korea. At the heart of our dialogue lies a shared ambition to build resilient, prosperous societies that are not only economically competitive, but also environmentally sustainable. In this regard, I would like to express my sincere gratitude to the Che Institute for Advanced Studies, the Korea Foundation for Advanced Studies, and the Jean Monnet EU Center at Korea University for their invaluable support and dedication. Their commitment to fostering academic exchange and dialogue has been instrumental in bringing us together for this important conversation. The Nordic region has set a clear and ambitious goal to become the most sustainable and integrated region in the world by 2030. This shared vision, adopted by the Nordic Prime Ministers, is more than just an aspiration. It's a roadmap for transformative change. The vision is guided by three principles, priorities: a green Nordic region, a competitive Nordic region, and a socially sustainable Nordic region. Together, these principles shape the way we develop policies, industries, and partnerships. Sweden, as part of this collective Nordic journey, plays a pivotal role. Sweden has demonstrated that economic growth and environmental responsibility can and must go hand in hand. Since 1990, we have reduced our carbon emissions by 31%, while increasing its GDP by 91%. This remarkable achievement challenges the notion that progress must come at the expense of the environment. Sweden offers a real-world case of how innovation and policy can align to achieve both prosperity and sustainability. Sweden, like Korea, once had an energy-intensive, manufacturing-driven industrial economy. But with foresight and collaboration, it has moved decisively towards a low-carbon future. In 2021, Sweden established comprehensive roadmaps across 22 key industrial sectors, from electricity and heating to agriculture and gas, each tailored to support carbon neutrality while preserving economic vitality. The roadmaps are not isolated plans, they are interconnected efforts that reflect the Nordic model of integrated governance and long-term strategic planning. Innovation is a central part of Sweden's success. Sweden is driving its sustainability agenda through a dual transformation that integrates both digital advancements and green initiatives. Leveraging AI, advanced analytics, and new technologies, Sweden is paving the way for a sustainable future. Importantly, electrification has emerged as a core enabler. Reliable, clean, and stable electricity is the foundation of any green transition. As an example, Minesto, a Swedish marine energy technology developer, is enabling sustainable energy solutions by producing large-scale electricity globally from areas where no other known renewable technology can operate. Another notable initiative is the Stockholm Exergi, a partly government-owned energy company that supplies 800,000 people in Sweden with energy. In 2024, Stockholm Exergi announced a permanent carbon removal agreement with Microsoft, the world's largest to date. This showcases Sweden's electrification ecosystem, powered by renewables, anchored in public-private collaboration, and supported by strong regulatory frameworks. It's a blueprint for the future. But these advances have not happened in isolation. Swedish companies have been pioneers in adopting new practices and have seized opportunities arising from global challenges. They are proving that the private sector can lead alongside government, fostering resilience, innovation, and shared value across industries. Sweden as a nation has ambitious goal to have 100% carbon-free electricity by 2045, a goal that can be realized through a flourishing relationship between industry and government. The challenges faced, from climate change and biodiversity loss to rising energy demand, are global in nature. The actions of one country inevitably affects others. This is why the Nordic region is committed to international partnerships, to learn across borders and sharing practical experiences. Today, as we deepen the dialogue between Korea and the Nordics, we do so with the belief that collaboration multiplies impact. By connecting Swedish know-how with Korean innovation, we open new possibilities, not just for green growth, but for co-created solutions that address global challenges. Together, we can work to accelerate the green transition towards a more sustainable future. Let us be inspired by our example, by Sweden's example, not as a finished model, but as a dynamic story of what is possible when vision, policy, innovation, and international cooperation are aligned. And let us use this moment to strengthen the ties between our regions, guided by a shared purpose, to build prosperous, inclusive, and climate-resilient societies for generations to come. Thank you very much. Thank you.
Thank you very much, Ambassador. And thank you for setting the stage for this event and highlighting the importance of collaboration between government and businesses and also other parties. Next up, we will hear from one Swedish company. It's actually a Japanese company, Hitachi Energy. But as you may not know, Hitachi Energy is former ABB Power Grid. So most of the development, production, and research and development takes place in Sweden. So we are very happy to have today here Dr. Arman Hassanpour, Regional Representative Director for Hitachi Energy Korea. So welcome to the stage, Arman.
So, good afternoon, everyone. Happy to be here. Thanks a lot to Mr. Ambassador, who already explained really well the establishment of this event. Actually, we started 2 days ago, and this is a continuation. And today we talk about the electrification. And I will explain that's why we are still proud to be Swedes, not that Japanese. In 2 slides. First of all, Hitachi Energy, the name still sounds like Japanese because they purchased our shares 3-4 years ago. But we have a totally globalized footprint. We have a global footprint, and the headquarters actually is in Switzerland, in Zurich. We have around 45,000 employees all around the world, and a lot of offices and facilities in different countries, including Korea. So the technology that I'm going to talk about today actually originated in Sweden back in 1883. And that's the place that we are really proud that we still kept our footprint there in Ludvika. We have had the ASEA company at that time, and quite a lot of nice and interesting milestones, like 1954, where we had the first HVDC project in the world, that we could connect the Gotland in Sweden to the mainland of Sweden through the HVDC link, high voltage direct current cable. And then later, back in 1988, the BBC company, this is not that news agency, this is Brown Boveri, a Swiss company, merged together with us. So we had the ABB time, which started in 1988. And then it continued the development for the transmission and also the distribution and generation side. A lot of, again, milestones, like 1997, we had the first HVDC light tested in Helcom in Sweden again. And then recently, 2020, that was the time that Hitachi purchased the power grid section of the ABB. And again, we continued our transition. But we kept all of the footprints, the facilities, the resources, engineers, and technology, and all of our collaboration and innovation center in Sweden. That's why we are still very proud to be Swedes. The scope of the company is actually quite broad in the full energy value chain, starting with the generation side, to the transmission side, and also to the distribution. And I can proudly say that like 130 years of partnering with different utilities all around the world, including Korea with KEPCO. And also for renewable energy, we have around, let's say, more than 220 gigawatts onshore and 48 gigawatt offshore installed base, which is quite a lot, I would say. But then today, since this is quite a specific innovation talk today, I want to focus on only one technology that we call it HVDC, which is a technology which is quite advanced compared to the conventional AC system. And this technology is actually based on the conversion of the AC, the alternating current, to the DC, which is the direct current. So for those who are not really deep into the techniques, I can say the differences is like you have the generation of the electricity which is based on the rotation. So whenever you have rotation, like based on the turbine which is turning, and then you have the rotating, and then you have the electricity which is produced out of this generator. Since it's rotating, then the output is also alternating. So alternating generator means alternating outcome. But then if you just transmit the same power with the same attitude, you get a lot of loss. Means that the energy just disappeared as a heat or different types. But then what we can do, we can change the essence of this alternating sense to the direct sense. Means we can utilize much more of the power. So we call it like a HVDC, we call it high voltage direct current transmission. And to do that, actually we need to build a couple of converter stations. So you have the grid, the AC grid, which is based on any generation, hydro, wind, nuclear, whatsoever. And then you build a converter station where you convert from AC to DC. Then you transmit it, let's say very low loss. And whenever you need it again, you build another converter station and then you transfer it back. You convert it back to DC. So with this way, of course, you need to build two stations, but you get a lot of new values. You get lower losses, means more power. You get controlled power flows, means more stability in the system. You get a smaller footprint, which is more sustainable. So if I want to just highlight only the environmental benefits of the DC against AC, I can easily mention that for the underground cable, you can reduce by minus 30%, and for the submarine cables by minus, let's say, 50% reduction when it comes to the CO2. And if you look at the corridors that you need to transmit the certain amount of power, whenever you have the HVDC connection, the cable or overhead line, you can fully utilize your whole corridor. Means that instead of having, let's say, 3 towers, overhead lines, you can just build one. Or if it is cable, you don't see it even. So this is much more environmental friendly. So let's take a look on a few scenes of the first HVDC project that we built in Gotland, in Sweden, connecting Gotland Island to the mainland of Sweden. So these are some videos from that time. And then you will see that gradually we just exported this system and this technology, this solution to the rest of the world. And I'm quite proud that we installed the first voltage source converter here in Korea last year. So we commissioned it December 2024. Today we have around, let's say, 50% of the market share for the HVDC stations, which is basically all continents and almost all of the countries. So HVDC is working as a backbone of the electrical system, which increases the stability of your system. And that's one of the major benefits when it comes to the HVDC solutions. Then let me show you just some of the projects. So you see these days, most of the countries are connected through this technology. Let's be more specific. So this is a map, just focus on the north part of Europe. Almost all of the countries in that region are connected through this HVDC connection. So we have NordLink, we have a connection between Norway and UK, we have a connection between Norway and Germany. And how it helps, actually, whenever you need power in, let's say, Germany, and then you need the clean energy from the hydropower plant in Norway, then you can just transmit it easily through these links. So it is kind of a connection between different countries, which is enhancing the stability of the system. And that's just the start. Nowadays, you can easily see that most of the TSOs, the transmission operator, including Korea, they have a long-term plan for their electrical system. Professor Jung will later show the same model for Korea, but I can show a couple of examples, like here in UK, you see all of these lines are the planned HVDC by 2036. The north of America, the same. Italy, the same. So almost all of the countries, they have already started to understand what are the benefits of this technology, and they try to utilize it. A case study, as I promised, to show you our first HVDC VSC connection here in Korea. This is the Jeju project. So this is a beautiful view of the Jeju Island converter station. So it was 2019 when we made a contract, or less a kind of a partnership, together with KEPCO. So in the same time that we started to design the converter station, KEPCO started to also do some design work in their side. And then 2024, like last year, we had the inauguration ceremony, which held in Jeju Island. And this is a picture. And then we handed over the station to KEPCO, and they are now running the whole project by themselves. This is one example in Korea. And let me also show you how that converter station looks like. So this is the converter station, which is located in Jeju Island. And as I mentioned, just remember that first kind of a figure I showed you. We have the AC grid, and then we have a converter station. It will convert from AC to DC, and then it will send it through the subsea cable to the mainland of Korea. And then in Wando station, in the mainland, we have kind of similar converter station, which is receiving, and then convert it back to the AC and send it back to the rest of the grid. If you want to look at inside the station, how we do this conversion, it's a little bit more difficult to understand, but it looks like this. This is the converter valve hole. And the reason that we say it's a high tech, because it's including almost all of the technologies from the chips in the dopings of the semiconductors to the cooling system to the high and advanced control system. So it requires a lot of kind of a subsystem that should be all connected together and work at the same time in order to stabilize your network. This is just a picture of Jeju converter station, but the Wonder station also looks the same. Since this event is quite a lot of about the innovation and how the Nordic innovation model works, I would like to one step back from the company that I'm presenting and just focusing on the sustainable innovation ecosystem of Sweden. And I want to show you how innovation happened in Sweden and when we started this kind of development in Sweden, what was the infrastructure, how the government, how the social supports really this kind of development. So in Sweden, we have a quite interesting innovation model, the Swedish Energy R&D organization. It also includes the government. So in a general policy level, we have parliament, we have the Ministry of Education, Ministry of Energy, Ministry of Environment. So we have different ministries who are setting the policies, the general policies. And these are very important. Then we have funding and policy supports, like probably you know Vinnova or Energy Myndigheten. So, and also quite a lot of connection to the EU. And then at the last part, we have the R&D performers. So we have universities and research institutes and industries who are doing the research. So all of this process, this ecosystem works hand in hand together, working together to make this kind of innovative kind of foundation for us. Quite a lot of interesting points, so I try to list it here. Like energy research is special in Sweden. We have a lot of collaboration between our company and universities. It is mainly funded by government, I would say, in Sweden. We have state-funded universities and very trustable environment. I think that's one of the differentiating points between the Swedish innovation ecosystem and maybe the rest of the countries. There is a really, really high trust between universities, government, and industries when it comes to the collaboration. We as an industry that have a footprint in Sweden, we freely talk to our counterparts in university. IP issues, the discussion on the patents or the intellectual properties, these are of course important, but they are based on the trust in Sweden. And I would say this was one of the most important highlights that I realized during the past 10 years when we were working on a very specific topic of HVDC with KTH University in Stockholm. And since this is, as I said, like our originate place for our HVDC technology, we have quite a big heritage in Sweden. Then a kind of a map of the academia and industry network that we have in Sweden. It's actually just to start with this picture in the map in the middle. The academia, we have different universities like Luleå, KTH, Uppsala University, Chalmers. I personally studied in 2 of them. So these are the performers of the innovation part. They do the research. We can easily give them some kind of task force. They can easily share their findings. We have a very frequent discussion with a lot of adjunct professors and the professors and associated professors and even PhD and master's students. So in different levels, very frequent collaboration. And I can tell you one example, like we have had a couple of years ago, we have, specifically for HVDC, we have had one PhD student who was studying in KTH, who came with kind of innovative ideas about one control system in HVDC, easily came to us. We supported with findings and put a lot of efforts on the IP and the patents. And that patent is basically based on his idea, which is utilized by us. But of course, the main beneficiary person is that person and the KTH. But again, this is like an example of like a trust between us. So you can easily share whatever is coming in your mind about the new technologies. And then on the other side, we have the funding organizations like Vinnova, like Energy Myndigheten as well, who are basically put the funds in place. And at the other side, we have industries and research institutes. So our company is one of them, Ericsson, Vattenfall, Ørsted, also you can name it, almost all of the industries in the field. So, just final words. I presented our company, and then I presented the ecosystem of the innovation and how it's happening in Sweden. But I would like to just get back to the first point that our ambassador also mentioned. We are in a transition to sustainable systems. But no country, no one person can make it happen. We need collaboration. This is a globalized activity. This is something that we need to do hand in hand. And I would say it is not only localized efforts. There are certain countries, certain mindsets which are old-fashioned and they want to do everything by themselves. And that's not really possible in this new world. So that's one point. So we need to be globalized. And then critical elements like supply chain. Now, as I showed you one map, all of the HVDC connection in different parts of the world. So you see all of the countries are fighting against the same resources. We are all fighting against copper. We all need iron. We all need semiconductors. And actually, this is a kind of a common supply chain that we all need it. So supply chain, timely logistics, and cost efficiency can be enhanced through an international perspective. And that's, again, come to my first point that we need to be globalized and do not really look in a silo way. And then, of course, here in Korea, by combining our international expertise with local resources, we are really committed to promote energy transition in Korea. I can also mention that this is not one way. Example was like Jeju project. This is not only one way that we support Korea. Korea and Korean industries are supporting us a lot. Not only the material, but also the resources. You can easily just walk through our office in Ludvika or Västerås in Sweden and see a lot of Korean faces. That's the first indication. So I would say the collaboration between two sides is a must. And I hope this kind of forums and speaks and talks can be initiatives. And I really look forward to hear the rest of the speeches. And for sure, if there are something that we can support during the rest time, just come to me and we can definitely discuss about it. So thanks a lot. And I hope you enjoyed this. Thank you.
Thank you so much, Arman, for giving us that very interesting lecture about HVDC, your technologies, and not least how you both contribute and benefit from the Swedish innovation ecosystem. One of the companies that you showed in that slide with industry, academia, and government is Ericsson. It's one of the most research-heavy and innovation-heavy companies in Sweden, and I'm very happy to be able to present today Dr. Sibel Tombas, the CEO of Ericsson Korea, who is our next speaker. Please welcome her to the stage.
Thank you very much, and warm welcome everyone. I think I will actually build on what Dr. Arman said. I'm actually has been part of that flow and ecosystem in Sweden. I moved to Sweden as a PhD student, actually studying sustainability for wireless access networks more than 10 years ago, collaborating with Ericsson, then part of the Ericsson company. As an early researcher, continue my research on sustainability in a broader sense, and then work in the portfolio to make them energy efficient. And now I have the honor of recently moved to Korea, hopefully bring all the innovations and product portfolio, not only for our direct customers, which is operators and CSPs, but more importantly, to the larger ecosystem of companies who we strongly believe that digitalization will make a huge impact to make this green change faster. Because I think it's very, I'm sure all you acknowledge, we don't have time to just discuss, we need to act fast. We already passed the critical times for discussing. I also, as a person that come from technology, I believe that there is a lot of innovations that are piled up that is ready to be used. We indeed needs to continue to do more, innovate, but there are a lot of products, portfolios, innovations are out there. We just need to act fast and operate and execute. So I think that's a bit of the background of myself and a bit of the key message as well. But at the same time, of course, I will just present a bit of the company for those who don't know enough and highlight what do we do. It's very easy to tell what you do, right? It's always easy that what someone else should make a change, but what do we do in Ericsson? And according to how do we impact the larger ecosystem to really make this transformation to digitalization and green growth faster? So we are a company that we are very proud. We have already more than 100 years. Soon we are going to celebrate 150 years. These are our inventors, Lars Magnus and his wife, Hilda. They were working on telegraph in early days. Many things changed since then, but one thing hasn't changed. That is the passion for innovation and passion for communication. And the main foundational idea was that communication is not only a human need, it's a human right. And that still stays with us, and that will continue to be so. And now, after 150 years, we are a large company with 100,000 employees. That's 1/3 of it is less than 35 years old. Very good, very young leaders, people coming and innovating every single day. We are serving in 180 countries, and we are clearly a mobile world leader. We have more than 60,000 patents in the mobile connectivity, and we are running 50% of global traffic outside of China is running through Ericsson network. So we are super proud, and again, it just shows the strength we have that we have been building 150 years. But we are even more excited about the pay forward, because we are investing and extending in different areas, and especially enterprise. And enterprise is not only for just connectivity, because we believe the connectivity will make even larger impact as we talk about digitalization and sustainability. So this is a bit of our global presence. As I said, we have 100,000 people. We are basically in all the different countries. We have the market area teams working close with our customers in the local countries in these 5 different regions. But we also have a very resilient manufacturing setup where we actually have many factories around the world. This was a strategy definitely to help in this current geopolitical situation, but we have been actively investing in different markets and creating our factories for a resilient and secure manufacturing to be able to reach to our customers faster in a more secure way. And again, going back to sustainability, as I said, it is nothing new for us. We have been focusing on sustainability for a long time in Ericsson. Actually, we have written our first report on sustainability in 1993. As I also mentioned, when I first started in Ericsson in 2014 in the sustainability research, which I thought sustainability was only about energy consumption of the networks. But then when I saw and met these amazing people that are working on every single piece that you can use for the materials, supply, manufacturing, lifetime. Very detailed research has been happening with calculations, reports, because the facts are only way to be able to see where you can make an improvement and impact. So that definitely shows that for Ericsson is really in our DNA, is really our core. We believe mobile technology is essential to make an impact, and impact for life, society, in addition to, of course, economy. But in general, I think these are the key milestones. I will not go that much in detail, but one, I think, big milestone I will say is when we set a very clear ambition to ourselves, and that is in 2021. We said we have an ambition to be net zero for our own operations by 2030, and we want to be net zero across our supply chain by 2040. And I will come back to our numbers and where we are, but these are very, very high ambitions considering that we have hundreds of suppliers, and we are basically working in a competitive environment that we don't have a similar ambition for our competitors. But we are very proud for that high ambition and the fact that it's not only a simple target, it is incorporated in all our decisions in the company. And so we're also very proud that our target has been achieved and approved by science-based climate targets, and we have been following that in second time. I think this, since we are all here, I don't think it is anything new, but I just wanted to put it here to create a sense of urgency. We know that we are living in the hottest years that I think we have experienced, and in our lifetime, even higher. And we are already coming to a point where reaching the 1.5 degrees threshold is becoming not achievable. So we come to a time that the signs are very warning, the activities needs faster and more urgent actions are needed, not only, as I said, from technology, but from regulators, collaboration, anything that we can do to really look at the problem in a holistic way and to really turn this trajectory in the right direction. Because as we can see here, we are not really doing right now what we should do in the sense of urgency. So what should we do? I think, again, I will present our activities in these 4 different ways. So first, of course, we should all be looking into what is our own emissions and what can we do to go to net zero from our own activities. Second, we should be looking at our value chain, because this is the place that we don't have control, but we can influence, and we can influence quite a big impact to really reduce the emissions across our supply chain. And finally, we need to provide solutions, products, services, solutions that enable others. And that is the area that we are right now very passionate about, and that's where the enterprise business and digitalization and connectivity with the power of 5G, we believe it can really make a huge impact. And finally, we need to accelerate the climate action. It is through this kind of meetings, through our dialogues, through our discussions in different forums, regulators, governments, driving cross collaborations, ensuring that we have the right forums to measure and act and report. All these things are essential to create a spiral effect to make this topic high in the agenda in every discussion. And again, as we said, this is at the core, so we believe that technology is essential for us to not only improve the lives, it can redefine businesses, and it can, most importantly, pioneer for the sustainable growth. And again, today we have a strong position, that's why we feel as an accountability, as a leader in mobile networks, being there for 150 years, and now with our focus extension to enterprises, with the technology that we have and with the focus we have, we really believe we can make an impact, both for technology investments, very targeted investments to make the changes and create the solutions, but as well as for partnerships to bring it further. Some numbers, this is just for number 1 and 2. When we look at the totality of our Ericsson's carbon footprint, only 0.5% of it from our own activities. And even that, we just don't. For us, we need to optimize every single digit. Supply chain, around 6%, and the remaining is from 94% of our portfolio, which is used by our customers, which is mobile operators, are mainly today. So what is our target? I mentioned the high-level target of net zero 2040 and 2030 from our own emissions. But again, we just don't set these targets and sit and wait, because it is just too far away. We created detailed targets for each year that we are following up. For by 2030, we would like to have, not only for net zero from our own activities, we would like to be 50% reduction from our own supply chain and 50% reduction of our portfolio that is used by our customers. And 2025, which is this year, we expect to have 36% reduction of our supply chain. We have 40% reduction of our own portfolio power consumption, and we also have 350 suppliers that we aligned for our climate targets. And I'm very happy to say, I'm very proud to say, that currently we are going to exceed these numbers. I already know that last year we have achieved 44% reduction on supply chain emissions compared to 2020 levels. So it means that when you put the right targets, when you put effort on it, and you measure and you follow, things are achievable. As I said for the suppliers, suppliers, again, we have 350 suppliers. So how do we achieve that? We achieve that through putting these very specific targets, by putting them in a formal way, find the right KPIs to measure and execute. And we make our decisions, our supplier decisions based on these KPIs. If we see that there is not performed, we change. I know it's not as easy, there's a lot of other things, but again, it's really, I strongly believe, if you put the sustainability as an important KPI for your decisions, not as a sidetrack, as an outcome, things are possible. And I think our numbers and our execution shows that trend. So, okay, now hopefully we're on the right track for our own consumption and as well as our suppliers. But then what do we do for mobile operators, which is still the largest part of it? 94% of our impact is coming from the portfolio that we create that is used by the networks that you are using every single day, several hours a day. So it's an extremely important infrastructure that needs to be maintained, especially with the projections. It has to be there because it will be even higher demand. For today's network, for mobile networks, they basically spend around 25 billion annually on the energy cost, which is, of course, like business-wise, there's a big impact. But again, when we look at the totality for mobile networks, I think it counts for 0.5% of the total carbon emissions of the world. Small, but still, again, we need to optimize every single digit. Again, when we look at where we are today, only 43% of the mobile industry has committed to a target. Even the ones that have a target, we are talking about 2050. And again, when I look at the numbers, 57% doesn't even have a target. And these are the small things that we need to accelerate. And I hope in the case that this is driving both the business impact because of the energy cost and the sustainability, and the fact that there's a very important critical infrastructure, I hope things will go faster. So what do? We continuously work on innovating and finding solutions so that there is a momentum to be able to make this as efficient as possible. And we call it breaking the energy curve. So how can we make this critical infrastructure as more efficient as possible? And we believe there are three key main things that we need to do. First, and again, I come to the same thing, and I think probably some of you engineers or had some math course, the only way to solve a problem is to write the right problem formulation. So if you don't put the right KPI in what you want to optimize, you will always find the suboptimal solution. I think it's where we are right now for mobile networks. We are optimizing capacity, we are optimizing performance, we are optimizing business, we are optimizing revenue, but we are not really optimizing energy consumption. So that's why we believe that we need to look at the network evolution with sustainability in mind, with the right KPI, measuring the energy consumption and the carbon emission. That's step one. Step two is, of course, while we are innovating, we are basically coming to a new variant of our portfolio that has higher reduction, maybe 20, 30, 40% reduction of generation over generation. So it means that innovations are there, the pace is there. But when I look at the Korea networks, the ones that you are connected to today, the 4G network is 15 years old. The hardware that is out there consumes several magnitudes of higher consumption compared to the best portfolio, the best products is out there. So again, how can we modernize? How can we make these faster changes and catch these innovations and include them in our factories, in our outdoor networks, in every businesses? Basically, I think that's another part. And second is operation. When you have that, we need to be super autonomous and ensure that we don't waste every single watt in the network. So how can I use AI, machine learning to operate the network so that we match the demand with the consumption in the most possible way? And I think we are in the right track. So as I said, we have been really focusing quite a lot on our portfolio. This is in line with our bigger targets I mentioned, but it's also, we believe, is an extremely important competitive advantage to really bring these innovative solutions. And then when I look at this, so here you see one site that has been, let's say, 24, 5 years old. And with our newest portfolio, if we can change these sites and add 5G, you can actually increase the capacity by 10 times, which means that you're actually creating a future-proof network while reducing the absolute energy consumption by 30%. So I think these are, again, a big pace in innovation. It is not only one solution, it includes a lot of multiple innovations with our partners to make it happen, and we continue. We will continue to create the best products in the market to really make an impact. Okay, but then what should we do next? So again, so far I talk about what we do, what we deliver, hardware and software solutions. There are still a lot of things that we can actually make an impact in the totality, but we are also even more excited about what digitalization to the other industries can actually make an even bigger impact. So based on World Economic Forum, they estimate that digitalization can reduce the carbon emission by 20%. I think that itself kind of tells about the high potential that we are sitting on today. And we believe that existing technologies with mobile connectivity can transform many industries. And again, I feel like so far this digitalization topic was more like, okay, why? It's okay, operational efficiency, is autonomous networks, is to make things easier, maybe some of the, but I think I would say it in a different way. I was visiting US last year. Of course, all of you probably reading what's happening in the world with many transformations happening at the same time with AI, with cloud, with 5G connectivity, all coming together. In my mind, if industries doesn't act, I don't think they will even survive, frankly. So we need to digitalize to be able to create data. We need to access the real-time data of any businesses in any type of devices, any type of information is flowing in that business. And that will be the foundation for creating a sustainable growth, but not only for like business growth and operational savings, it will affect a big impact on how can they also impact the carbon emissions by reducing waste and improving the overall efficiencies. So, and we have solutions for that. So because normally, so far, we have been focusing on creating wide area networks because our customers were mainly mobile operators. But when you go to Hitachi or we go to other kind of enterprises, their needs are separate. Their size is smaller. They need much more compact solutions, and some of them has very high security requirements. The other one has maybe less. The reliability requirements for energy sector is higher. So you need a different type of network that is built on the strengths. And we have different solutions for different needs. We are building private networks, the networks that are requiring, as I said, more on-site connectivity, that are much more secure, much more resilient. And these are the things that cannot be achieved by the existing technologies like Wi-Fi and others. But for other industries, maybe the dedicated networks are not sufficient or are not required. And the beauty of 5G is that we can create one big network, public network, but with network slicing, we can actually create virtual networks with delivering the required SLA for that industry, which is unique, which is a solution is out there in the last 5 years. It has been started to be used in some countries like US, but we are not there, especially in Korea. Unfortunately, since the regulations, since the networks, since standalone readiness, we cannot even use these existing solutions in this country yet, which I really, really hope we can make some change in the near future. Again, other things for wireless WAN, for especially to enterprises that has more wider area, there are like more different distributed locations that need to be connected. And again, this is also perfect solutions where you have different, maybe private network, but the management needs to be kind of coordinated. Especially, I think, again, I'm looking at the Aman for the energy sector. So the solutions, well, I want to say that the solutions are there, and we really strongly believe the connectivity can make a big difference, can really drive a huge operational savings and huge removing the waste of energy, and according to bring growth for these companies, which I again believe in the world of AI and data. If we don't, I don't think many countries and companies will survive. So these are also some of the kind of the areas or the enterprise that we think there is quite a big potential that we are specifically focusing on. Manufacturing, energy for ports, mining, agriculture, transport. And we choose them as in terms of focus areas, both in terms of the impact and the size, like for the carbon emission impact, in terms of where they are in digitalization. I think most of them, unfortunately, they are relying on quite old and distributed systems, not really coordinated. I think some of these kind of businesses, they don't even have connectivity to their own equipments. But again, we are living in an era where we have connectivity that can have billions of connections can happen at the same time. You can have indoor and outdoor positioning with resiliency. You can have security. So all the foundational things are out there, but we are just wasting power. We are creating even more hardware. We are probably using much more trucks that we probably need. Again, all of them because we don't have an access to real-time data. We just don't know what's happening, and we are preparing for the worst-case scenario. And all can be changed. So, I mean, now maybe one example for the energy sector. Again, I think this is one area we really strongly believe that the impact can be even larger, because this is a network that all the grid needs to be connected. Today, they use every possible connectivity. They use microwave, they use fiber, they use Wi-Fi. None of them are connected, none of them are coordinated. There is no automation, there is no real-time data. And none of them are basically available. And we believe this is one sector that, and with our engagements, has quite a big significant impact with the solutions. So what can we do? We believe that we can truly create a smart grid with the capability of 5G connectivity, that we can create to manage large number of power grids, and we can measure and understand the fluctuations. We can introduce flexibility for power management. We can have observed all the assets. We can drive AI-based automations. We can look into the observability just to understand in detail what's happening. And also when you look at the bigger scale of the infrastructure, we can also optimize the distribution. Because today we are preparing for bigger peaks that requires larger investments in terms of preparedness for these larger peaks. But we can do, when you have all this data, you can match your power demand with the consumption. So you can basically optimize even your infrastructure in a completely different way where you didn't have this data before. So these are, I think, just few examples where connectivity in this larger part of the network, where you get the information of the consumers to your grid, to all the components in between and transport, you can actually completely redesign and reoperate the network in a different way. And I would like to finish with one latest innovation, which is actually touching in the same area of energy, but since we don't have the central solutions from the industries, we created a distributed solution. So what it means is that, and I don't want to go to technical details, even though I love it, but I want to mention what it does. So why we created this solution is mainly just look at solving CSP's problems. So what is a CSP's problem? First, they pay a lot for OPEX, for energy, but also when they have the systems, so they are not really they don't know their consumption, they don't know the availability of the power from the power grid, and they have all the batteries, but they probably overuse the batteries because they don't know in the worst case because they need resilient network. So as a result, they have a system that probably they pay more than they should based on the demand. They not really use any benefit from the transaction with the grid. And at the same time, they are over-dimensioning their sites to have the reliability. And we solve that by a distributed system where we have this intelligence at the site. So we are basically acting as an agent between the mobile network and the power grid, with continuously understanding and analyzing to see when is the right time, how much the power is available, and how to orchestrate based on the consumption and the data, how we know that the site is using the power based on all the devices that are connected, and they are using the best possible decisions. And again, things are possible. These are the solutions that are being used by the lead operators, but the bigger impact is possible if we do it centrally by the enterprise. Because this bringing the solutions, we will do that in the mobile, but this is only one industry over thousands. It just shows the technology is there to make a bigger impact. So overall, I would like to end, again, maybe the same notes. I truly believe the focus on innovation. I truly believe all the great minds with the focus on the world and our biggest challenge that we are facing. And I also believe that we cannot think about the solutions anymore in a silo way. They will impact each other. Connectivity impact industries. There are other energy things will impact the connectivity. So we need to collaborate better. We need to create all bring the innovations better. And we need to get benefit from the solutions that are out there that they can make an impact today. So I would like to just, as a last word, hopefully create a sense of urgency for all of us as responsible citizens and responsible people in different part of the ecosystem, not only to innovate, but let's just find solutions. How can we execute and bring them to operations much faster? So thank you very much.
Thank you so much, Sibel, for that very interesting lecture. I think I take to heart that you put a strong emphasis on the fact that innovation is not only the research and the ideas, it's about action. So with that in mind, we have now heard from two companies and from our ambassador kind of representing government. Now we will hear a little bit from academia as well. We're very happy to have here today Professor Jang Gil-so, Dean of Korea University College of Engineering, and a lot of other titles as well, a real expert in these issues. So a warm welcome to you.
Yeah, good afternoon, everyone. So I'm Gil-so Jang from Korea University. Today I will talk about how Korea is transforming its power system using advanced power electronics technology, especially HVDC and FACT. Let me begin with a brief overview of Korean power system. Korea is completely islanded grid. We don't have any international connections. This means full self-reliance in grid management is required. Also, most generations is located in coastal areas, far from Seoul. Actually, Seoul is a load center, so it means we have a very big stress on transmission system. Korea currently operates 26 nuclear reactors with a total capacity of 26.1 gigawatt. An additional 7 gigawatt is planned. Nuclear energy remains a key part of Korea's strategy for stable and low carbon electricity supply. Remote coastal large plants create a strong regional imbalance between supply and demand, putting pressure on our transmission system. Korea aims for net zero carbon emission by 2050 through sector-specific actions. Actually, Professor Yoon is in charge of these things. So, key strategies include renewable energy expansion and electrification of many industrial processes and transportation. Korea's electricity demand is projected to reach 129.3 gigawatt by 2038, growing at 1.8% annually. To meet this, we need 10.3 gigawatt of new generation effective capacity and 23 gigawatt of long duration energy storage. Korea's recent plans to increase total renewable and new energy capacity to 125.9 gigawatt by 2038 Solar and wind make up most of the rated capacity, but their effective contribution is much lower due to variability, only 14.3% for solar and 2.4% for wind. This gap underscores the need for storage and flexible resources to ensure system reliability. This slide highlights a key challenge in Korea's renewable deployment: geographic imbalance. As you can see, Honam region, including Jeonbuk and Jeonnam, dominates in renewable generation, especially solar. This concentration creates transmission bottlenecks and make grid operation more complex. Jeju Island is Korea's carbon-free testbed. With abundant wind and solar resources and independent grid, Jeju is ideal for testing high renewable integration. The island aims to achieve carbon neutrality by 2030, 2 decades ahead of Korea's national goal. With only 18% renewables, Jeju already faces issues we expect to see nationwide: grid constraints, voltage fluctuations, and weak grid inertia. Now let's go to the second part, the current problems Korea is facing in its power system. Although Seoul area already have high concentration of electricity demand, even greater demand is expected as large-scale project. This slide shows the Yongin semiconductor cluster, which is planned as one of Korea's largest chip production areas. By 2053, the total power demand for this cluster is expected to reach about 14.7 gigawatts. In addition to semiconductor cluster, AI data centers are driving major power demand in the Seoul area. Most of these centers are already located in Seoul, and more are being planned in Seoul also. As electricity demand grows in Seoul, new generation is being built in distant areas, creating geographic mismatch. This increases the need for transmission. Grid expansion is often delayed due to strong public resistance and regional opposition. As seen in places like Miryang and Hanam, as a result, many power plants, especially on the East Coast, are unable to transmit their electricity. To handle congestion and reduce curtailment, Korea is rapidly deploying controllable devices in the power grid. As shown on the map, 6 HVDC rings and 12 STATCOM or SVC units are either planned or under construction. While controllable devices are essential for flexibility and renewable energy integration, their increasing numbers significantly raises the operational burden on system operators, requiring advanced coordination, real-time control, and robust system protection. As Korea has more converter-based resources, new types of stability issues are emerging. Traditional categories no longer capture these dynamics, so new types have been added, like resonance stability and converter-driven stability. These new challenges require updated evaluation methods and control strategies. Okay, so I think this is the old material, so yeah, I added 2 more slides in here. But anyway, okay. All right, now let's move on to a final part of presentation, how Korea is responding to these challenges. Korea currently operates 5 HVDC systems with 2 more under construction and additional projects under planning. These include point-to-point and back-to-back rings using both LCC and VSC technologies. As shown on the map, HVDC systems are being deployed to address grid congestion and connect key regions such as Jeju and Seoul areas. In the Seoul area, back-to-back HVDC systems are being introduced to reduce fault current and relieve AC line congestion. The Yangju back-to-back, rated at 200 megawatt, was completed last year. Another 500 system is planned in Simbupyeong. Inland HVDC projects have helped to overcome a strong public resistance to overhead AC lines. By using partially underground HVDC systems, public acceptance improved. These HVDC links also allow controllable power flow, which improves transmission efficiency. Already, the Aman explained about this very well, but I will explain it in brief. Jeju Island is connected to mainland by HVDC number 1 and number 2, both based on LCC technology. The objective is to import low-cost power from mainland. But as the renewable generation increases on the island, bidirectional power flow is now needed. That's why HVDC number 3, the technology is being added. Korea is planning an offshore HVDC backbone along the west coast, dedicated to connecting large-scale renewables. This will serve as alternative to inland AC lines and to support grid stability. While the project offers flexible and strategic interconnections, challenges remain, including high cost, need for advanced control, and domestic technology development. This slide presents my proposed long-term vision, a U-shaped offshore HVDC network that extends to the West Coast HVDC backbone. The network would connect major offshore wind and renewables, enabling efficient transfer of excess renewable power. By avoiding new inland corridors, this plan supports a more flexible and resilient national grid, especially as the thermal power plants are gradually phased out. As my own proposal, I suggest building a multi-international offshore HVDC network based on hub and spoke model. Each country would aggregate offshore wind at national hubs and exchange electricity through cross-border HVDC interconnections. This concept significantly enhances power supply diversity and resilience in Northeast Asia. In low inertia grids, it becomes harder to maintain frequency and voltage stability. Grid forming technology addresses this by providing autonomous voltage and frequency control and even virtual inertia. Korea plans to deploy this in Jeju with grid forming type ESS and ESTECOM, helping stabilize inverter-dominated grids. To support Jeju's low inertia grid, Korea plans to install a flywheel type synchronous condenser. It will enhance both reactive power and inertial support as renewables grow. ESTECOM combines a traditional STECOM with energy storage, enabling not only reactive power control, but also active power support. It can emulate inertia and regulate frequency using grid forming control, making it especially useful in weak grid. In Jeju, just one ESTECOM is planned to replace 2 synchronous condensers, showing its high efficiency and compactness. Okay, this is just the comparison of ESTECOM and conventional the synchronous condensers. As Korea rapidly deploys HVDC and FACTS, new operational challenges are emerging, especially in low inertia grids. The recent Iberian blackout reminded us how unpredictable converter-dominated grids can be. To manage this risk, we need global cooperation. Already Aman expressed the importance of this shared running, standardization, and joint control strategies. Most importantly, we must collaborate on real-world data integration and coordinated HVDC FACTS control. We sincerely hope to work closely with advanced Swedish companies to build a more stable and resilient power grid. Thank you for your attention.
Thank you so much, Professor Zhang. Very interesting to hear your ideas on how to push this forward, and you're underlining the fact that we really need to cooperate if we are to solve these complicated problems. We will now have a panel discussion with the experts, so it will take a few minutes to set up the stage. Please.
Good afternoon, everybody. It is very nice to be here because I didn't expect this big volume of audience. Yeah, so it means the topic of this session is very attractive and it is a required subject in these days. As he introduced, I'm Dean of Graduate School of Environmental Studies of Seoul National University. Also, I'm President of Energy Transition Forum Korea. So it is very nice to discuss this kind of essential topic today. And actually, I think what I talk is translated. So anyway, I think if I speak English, it will be translated into Korean. If I speak in Korean, it will be translated into English. So in that case, it's better for me to speak in Korean. Anyway, it will be translated. Is it okay? Or maybe I can speak English. Yeah. Anyway, all your presentation was very impressive and very inspiring. But because of the differences between Sweden and Korea, especially not just technological nature, but also social and political structure or the nature, maybe even though the same technology is applied, maybe the result can be different because especially our electricity market is different from others. As you know, our electricity market is TEPCO monopolized. So I'm not sure when all of you presented, the focus was given to technology. So technology should be maybe connected with or involved with social issues. So especially Professor Zhang already mentioned we have some problems when we expand our transmission lines. We have very serious social resistance. So such kind of problem, how we can solve such kind of problem, it is one of my questions. But anyway, I will say just English. Yeah, I prepared several questions. So please, just very simple questions. So I think it's better for us to share this kind of questions and answers. Concerning the Ericsson Korea, in which industrial sectors does Ericsson see the greatest potential for digitalization-driven decarbonization, and why?
Yes, I think as I tried to highlight in my presentation as well, so I think we generally believe in the bigger scale. So for me, any industry that can benefit from digitalization, it will have an impact on sustainability. But when we look at where we focus, again, I think we are trying to customize solutions because every enterprise and every industry is unique. Their needs are unique. But we are trying to focus on the ones that has larger carbon impact. They are less in digitalization, and there's definitely change in their networks needed. And mainly we focus on transport, mining, manufacturing, and energy segment. These are just few. But again, some of the solutions are also quite easily be used for smaller enterprises as well. But as I said, the main reason of selection is the scale of these industries in general. They have a bigger impact on carbon emission today. And again, also we believe that where they are and the impact of digitalization will be much larger than many others, because they haven't yet started and they still use quite hybrid tools that can definitely change. And we believe connectivity make a big impact.
When we think about the technological development, actually in terms of efficiency improvement, we think about rebound effect. So if we have more and more advanced technology, maybe people think it's very easy or convenient to use such technology. So our usage time can be lengthened, and it can result some kind of big consumption. So how Ericsson deal with the effect of rebound effect?
Do you mean the consumption that the network will generate?
Yeah.
Sure. So I mean, maybe just start with some numbers, right? Even if my facts are correct, I mean, transport segment industries in general, I think they are creating 15% of the global emission, whereas the whole mobile connectivity and all mobile communication for connecting billions of people is 0.5%. And now we are talking about these networks and application of smaller enterprises. So in terms of the scale, I think the additional impact for that network is very small. Then that's one part. Of course, it doesn't mean that, as I said, every single digit counts. So what is the ratio? So even in that part, as I said, we do many things. First, does that technology is the most efficient compared to alternatives? And the answer is absolutely yes. So because we don't believe that 5G connectivity is only for connectivity. So it can completely remove all the Wi-Fi, which is itself reduce more energy than it consumes. And in addition, with the indirect impact through digitalization, and the efficiency that these industries will gain from their own consumption, the impact will absolutely be positive. So we are definitely not worried about the extra cost because of all the direct impact with removing the old technologies and deployments, and the indirect spiral effect to the industries who are reducing their own consumption.
I'm not sure you are taking with the technology of AI or other technology impact, because in Korea there are big concern about increasing consumption of electricity because of AI. So, but some people think maybe AI technology can contribute to efficiency improvement. So maybe the expected electricity consumption resulted from AI technology usage will not be big. So how about your opinion?
I mean, thank you for asking this question. So I think it's a great question. And I guess for me, one thing, and now I will talk about the AI application that I mentioned for these industries, right? And I will talk about with facts and numbers. Of course, for the overall, these bigger companies and their hardware that they use for the general applications, their consumption is one thing, and we can have a separate panel for that benefit. But if you focus on mobile connectivity, and we definitely believe, as I said, digitalization together with AI will make the reciprocal impact to the industries. And as one fact, for AI in our Ericsson network for enterprises, the compute that we use has 150 watts. So it is 1/6 of a fridge.
150 what?
Yes, just one compute that connects tens of hundreds of access points. And it has AI. So we run the connectivity and AI algorithms into the same board.
Oh, good.
So I think we are very well positioned because we are not running a general AI. We would like to have like connectivity and AI in the same board, and then we believe so the additional cost will not be high. Of course, I'm not talking about all the other AI applications that are out there, but specific for my example, again, the cost is not that high.
Good.
Because we optimize our hardware accordingly.
Yeah, I just give time for Sibel. So maybe two other men, just they are alone. I think so. It's better to raise some questions to gentlemen. So in case of Hitachi, as I already talked to him, I was surprised. I thought Hitachi is a Japanese company, but it is a Swedish. So, and I think Sweden is very impressive country. Before IPCC published the special report on global warming 1.5 Celsius, and the IPCC suggested net zero by 2050 in 2018. But before the issue of IPCC special report, Sweden already announced net zero target, not just by 2050. Sweden announced by 2045, so it was amazing. So I think Sweden should succeed, so it can give a good lesson to other countries. But anyway, so in case of Hitachi, what are the main technical or systemic challenges in integrating HVDC into existing AC-based power grids? And how is Hitachi Energy addressing them? Because nowadays, we have heard lots of questions or comments. There will be some problems in mixing AC with HVDC. So some people think maybe HVDC can maybe you mentioned altering something, so the technological nature is different. So how can go harmonize the way or simultaneously with AC and HVDC? So we already have many AC transmission lines. Nowadays we are adding HVDC. So some experts maybe criticized such kind of approach can make a big problem. So how do you think about such kind of comments or questions?
Yeah, right. For sure, that's something we can discuss about it. I can give you a kind of example. You can drive your manual car for all the time, but when it comes to the auto car, then the auto gears, then the complexity is there. You need to change your system, your gearbox, but the effort is really worth it. So this is the same with the HVDC. For sure, it will increase the complexity of the system, but the benefits that you will get later in the stability point, from the stability point of view, is quite huge, and that's necessary. So the challenges is there. Of course, the essence of HVDC is very different from the AC. I can give you example of Jeju 3 projects and how we solve that one. The existing network that you are going to connect your converter station to has already kind of a network model. It has already some kind of features. It has already subsynchronous harmonics, quite a lot of kind of network parameters. So we are going to connect a new system to the existing system. So the way that we solved that issue in Jeju was like continuous discussion and continuous studies in a simulation way together with the operator, which is KEPCO. So we received their network model. I can tell you easily more than 20 versions. So one day we received one model, we did our studies, we identified these might be the issues, we returned it back to KEPCO, they revised it, they sent a new model. So it was a kind of iteration until we solve all of the possible interaction problem between the existing system and the newly added one. And then when that's solved, we know all of the issues, we just implement it in the control system of our converter station. So there is a kind of iterative tuning process that the HVDC will go through. There is always a technical challenges, but the control and protection system in HVDC stage is very advanced, and then we can just integrate all of the interaction problem that might happen in future, together with the TSO who are the operators of the station. So I would say that's one way that we tackle. So stability is a huge issue when you are going to build a new and add something new to the system. But then through the studies and the simulations, we can just solve it.
Good. How about social, maybe response? As I mentioned, in Korea, we have a lot of social resistance against construction of a transmission line, especially it is high voltage direct current. So people do not know actually exactly what it is. But anyway, after Miriam resistance about the high voltage transmission line construction, it was a 765 kilovoltage transmission line. So after that event, people, normal people think, wow, transmission line is a very bad thing. So we should not accept such kind of a facility in our village. So everywhere, people do not like or do not want to accept such kind of facility. How about in Sweden or in Europe? Is there some severe social resistance? Or if you faced such kind of problem, how did you solve it?
Yeah, I think that the problem is basically the awareness. So people should be aware of this technology, and we need to educate them. The education is basically the thing. I can easily tell you the HVDC station is very safe. And I can give you again, if you have seen the movie Tesla, how he started to show the Faraday cage in his movie. Probably you have seen this movie. It was like a metallic cage that he built, and he went inside that cage, closed the door, and then he applied very high voltage on the top of the cage. So it was like lightning. So a huge amount of power just heated this cage, and then he was inside this cage. And then nothing happened. So we call it a concept of the Faraday cage. So whenever you have a metallic kind of a box, the whole of this electricity just goes around it and goes to ground when you have a ground point. So the converter station that I showed in my slides, the converter station, those buildings that you see, inside the walls, there are Faraday cages. Inside the walls, we have the nets, the mesh, the iron mesh, that is basically preventing all of the emissions, the high harmonic emissions, from the inside the building to the outside. So this is the way which is protecting. And I'm sure, and I don't of course expect everyone in the the people without those who are not working this kind of technical things knows about it. But this is just awareness. So we need to bring up the awareness, and we should educate them about this. The amount of the radio interference that you will get when you are standing out of the building of a HVDC station is less than a hair dryer that you use. And we have the operators, we have the people. Me, myself, I was at site for several times, and we are just standing behind the wall, which is inside. You have 525 kV system up and running. So if it was not safe, for sure I was not there.
Oh, yeah. So we need more communication, and you know, we have faced a lot of fake news too. So it was very difficult to overcome. So I think it takes time to communicate with the balanced information. So I think in this sense, your experience and your suggestion will help us a lot. That's a good point. Yeah, how about Professor Zhang? Yeah, your presentation was very nice, but as you mentioned, we have some mismatch between electricity production area with the electricity consumption area. So you suggested still the same pattern. Maybe with renewable energy, we can produce electricity, especially in Honam area, and we can transmit that electricity to the metropolitan area where electricity consumption demand is high. But should we maintain such kind of structure? Nowadays, people in Honam, they don't want to transmit or deliver their electricity into other areas. Just they want to accept some factories into their area, not just sending the electricity from there to other areas. So I read a new, article. It says about the effect of renewables pool effect. Renewable energy can attract or can pull factories in other areas into the place where renewable energy is abundant, because that area has some competitive power. Especially in these days, Ali 100 is very important. So factories need electricity made by 100 renewable energy. So such kind of, in that case, maybe we can have some balanced development of our nation. Nowadays, too many people in metropolitan area, and our income just go to metropolitan area. So we have some problems in countryside and not just the non-metropolitan area. So how about your idea about my point?
제가 한국어로 답을 드릴게요. 저는 지금 저 좌장께서 윤순진 교수님께서 말씀하신 그 부분에 대해서 저는 적극 동의합니다. 지금 우리의 전력 계통이 오랜 동안 대규모 발전원으로부터 싼 전기를 만들어서 그 수요가 있는 먼 곳에 수요가 있는 곳으로 송전선을 통해서 전력을 보내는 방식이 경제적이었기 때문에 지금까지는 그렇게 해왔는데, 지금 계속 이제 질문에서도 말씀 주신 것처럼 이제 그 수단이 될 수 있는 송전선을 지을 수 없는 상황이 됐는데, 과연 그 이전에 그 방법이 진짜 경제적이고 가장 적합한 방법이냐라고 하는 걸 생각해 보면 저는 그렇지 않다고 생각합니다. 그렇지만 이전의 인프라가 그대로 있는 상태이기 때문에, 그래서 어쩔 수 없이 지금 대규모로 발전소가 만들어져 있는 현재의 구조가 결국 소멸되기 전까지는 거기서 생산된 전기는 결국은 로드 센터까지 보내주는 방법은 필요할 수밖에 없다라고 생각이 들고요. 그렇지만 이제 점점 우리가 발전원의 발전 방식이 지금 오늘 계속 얘기하고 있는 것이 결국은 신재생 에너지원을 기반으로 한 발전으로 바뀌게 되면 조금 전에 말씀드린 이제 그러한 기반에서는 이제 크게 바뀌게 될 것이고, 그런데 거기서 우리가 이제 기대했던 것이 좀 분산화된 공급원을 기대했는데 신재생 에너지원조차도 특정 지역에 이제 많이 몰려버리게 되니까 우리가 기대했던 공급의 분산화가 조금은 우리의 기대하고는 조금 다르게 진행이 된 측면이 있습니다. 그렇긴 하지만 여전히 예전보다는 훨씬 나아진 환경이고, 또 그러한 환경 하에서 과연 그러면 지금 딱 교수님께서 질문 주신 것처럼 거기 신재생 에너지원에서 생산량이 많다곤 하지만 그 많은 것을 결국 그냥 수도권으로 그냥 보내는 것이 지금 현재 가장 좋은 방법이냐, 이제 그 부분에서는 현재 수도권의 수요가 크니까 그 발전력을 필요로 하는 부분이 있으니까 어느 정도 보내주는 것까지는 필요하다고 생각이 들지만, 추후에 더 이 신재생 에너지원이 지방에서 더 확장이 되게 된다면 그 에너지원은 당연히 그곳에서 생산한 것을 그곳에서 쓰는 것이 가장 효과적인 방법. 송전선을 이용해서 어느 특정 지역의 공급원에서 나온 전력을 어떤 특정 부하지역까지 보내는 방식 자체가 가지는 이제 장점은 거의 사라졌다, 이렇게 보는 게 맞는 것 같습니다. 하지만 지금 현재 있는 인프라에서 결국은 어쩔 수 없이 우리가 어느 기간 동안은 적어도 한 10년, 20년 이상은 그 인프라를 활용할 수 없는 상황이기 때문에 그 안에서 대안을 찾는다면, 제가 이제 말씀드리는 서해안에서 결국은 전라도 지역에서 그 소비량을 다 할 수 있다면은 물론 올 양이 없겠지만 현재는 아직은 그렇지 않으니까 거기서 남는 잉여량은 수용성이, 사회적 수용성이 해결될 수 있는 하나의 방법으로 HVDC를 통해서 오는 것이 필요하다라고 이제 생각을 합니다.
네, 답변 감사합니다. I think maybe such kind of approach is required for a certain time period, but I think maybe such kind of approach can be maybe fixed. We should be careful about. So I'm not sure how much such kind of system can be flexible. So we should make some decision. For example, in case of Yongin, there is maybe some facilities or infrastructure will be located. So before such kind of a new decision, we should take another pathway. That is my suggestion. But anyway, and another question I have is you suggested 3 countries connection, China, Korea, and Japan. But we say about Korea's condition is very different from European countries. They are all connected, but Korea is a peninsular country and divided country. So our situation looks like an island situation. So we should be connected with the other countries. But I think China, Korea, and Japan, our political system and economic system is not the same, and we have a very tragic history we have. So in our case, trust is not strong enough and solidarity is not big enough. So under this kind of circumstance, maybe your suggestion can be achieved or not.
Yes, 저도 교수님 말씀 충분히 이해를 합니다. 저희가 아까 이제 제가 발표에서도 말씀드렸는데 우리는 이제 아일랜디드 그리드고 다른 나라하고 인터커넥션이 전혀 없습니다. 이제 그런 상태에서 우리가 가지는 운영상의 이제 많은 제약이나 좀 경제적인 단점들이 있는데 그 부분을 좀 해결하기 위해서 중국, 일본은 관심이 없었지만 중국하고 러시아하고의 전력계통 연계에 대해서 오랜 동안 20년 이상 이제 그렇게 이제 얘기를 해왔는데 기술적으로 문제 없고 경제적으로 이익이 되는데도 못했던 이유는 딱 교수님 지적하신 것처럼 신뢰가 없기 때문입니다. 그러니까 지금 이제 중국하고 러시아하고의 이제 연계 사이에서 모든 게 거의 마지막 단계까지 갔는데도 안 됐던 이유들인데, 그래서 이제 제가 제안드리는 이제 그 방법은 그 부분을 조금 고려를 한 겁니다. 우리가 직접 지금 중국 산동반도에서 우리 인천까지 원래 2기가와트의 전력을 이제 수송하기로 했었는데 이제 그 부분이 이제 그 말씀하신 이제 뭐 정치적인 문제로 이루어지진 못했습니다. 이제 그런 상황에서 그런 문제는 결국 계속 발생할 수밖에 없다라고 생각해서 이제 제안한 것이 결국 각 나라가 그 해상 풍력은 필요하고 그래서 그 해상 풍력이 필요한 부분만큼은 중국은 중국대로 개발하고 일본은 일본대로 개발하고 우리는 우리대로 개발을 하고 그런데 이제 그 풍력이 가지는 그 일종의 그 변동성을 각각 다 이제 문제가 될 거니까 그 변동성을 세 나라가 같이 연계해서 그 이익을 얻자라고 하는 취지거든요. 그래서 이제 물론 전력계통의 연계라고 볼 수도 있지만 해상 풍력을 공동 개발한다는 측면으로 저는 이제 좀 접근을 해보자라고 하는 취지고 거기서 만든 전기를 이제 각 나라가 가져가니까 결국은 결국 이제 연계가 되는 방식은 되지만 그래서 지금까지 해왔던 그 방식하고 조금 다르게 접근을 해서 지금 이제 뭐 정치적이나 뭐 이런 신뢰 문제로 조금 이렇게 좌초됐던 뭐 이런 부분들을 이번엔 좀 해결해 보자고 해서 이제 좀 제안을 드린 것이 되겠습니다.
아마 그렇게 되면 그런 시설을 공유하고 함께 사용하는 걸 통해서 오히려 없던 신뢰를 만들어가는 그런 측면이 뭐 발생할 수도 있을 것 같네요. 예, 근데 제가 사실 질문을 더 많이 여러 개를 더 많이 준비했는데요. 그래도 저만 또 질문을 드리면 그러니까 혹시 is there some audience, if you have a question, just raise your hands and just speak your name and maybe just indicate which presenter you have a question. So do you have questions? Otherwise, I can go ahead with my own question.
Hi, I'm Brian. I'm an independent student. I'm not really used to this topic specifically, especially about electricity, but I think it's what I have as a question is a more fundamental one, which is tied to basically security and resilience. Like, I've noticed a lot of trends, especially with interconnectivity within technology and in grid infrastructure as well. And there's a lot of emphasis on centralization from what I've understood in this talk. And I just can't help but remember NotPetya, if anyone knows that. It was a widespread cyber attack that was commenced on Ukraine back in 2017, if I remember correctly, and it paralyzed a lot of infrastructure, key infrastructure. And I was wondering, is there means are there any kind of preparation or kind of safeguards that can protect against these kind of adversarial attacks on grids, etc., that are currently being prepared, especially considering the interconnectedness of the grids that are being developed? Thanks.
So,
I can maybe answer from at least grid point of view. 10, 15 years ago, whenever we had a project in any countries, cybersecurity was not the hottest topic. But today, as part of our contract, we always have cybersecurity basically on the top of the agenda. And the technical specifications has been developed around the cybersecurity for electrical grid. Yes, for sure, there are a lot of activities and proactive actions against the attacks and the outages. And cybersecurity, of course, that's something that we work on it days and nights. But it doesn't mean that because maybe there would be an attack, we just do not go ahead and forward in this direction. It means that we, of course, we are aware of such a problem and we do all of the preventive stuff that we can do, but we need to be resilient. And resilience means that if something happens, we can recover it very quickly. And that's also part of our recovery plan for electrical grid. But I think maybe Dr. Sibyl can elaborate a little bit more from the 5G point of view.
Yeah, thank you. I mean, it's exactly the same. I think 5-10 years ago, in the sense of connectivity, also security was not really high in the agenda, but right now is the number one discussion point in any dialogue we have with the customers, and especially I think you can see right now with what are one of the biggest operators in Korea with SKT, what is going through. So especially in communication, I think the information is also super sensitive. So what do? I mean, in the sense now in the discussions here, First of all, I mean, technology itself, we believe 5G in terms of connectivity is more secure than any other wireless connectivity that's out there. Both the previous mobile generations as well as all the other, let's say, generations are relying on different spectrum. So I think that's the one foundation which we definitely think is, that's the reason is we believe that technology itself is perfect for the enterprises. But we don't stop there. We have a huge investment on security in every area, both the products and portfolios that we produce, but also the solution that we allow CSPs to use for prevention, detection, and early adoption to be able to prepare ahead of time. And I really hope maybe in the short time we can bring the solutions to the Korean CSPs as well. But coming to the enterprises, then is one step further. If you remember my slide, I also mentioned that for this enterprise that is specifically security is even higher because of the, for example, utilities and electricity grid. I mean, this is not the system you can rely on in even a wide area network. That's why we have focused private network where the data is local, deployment is local, kind of encrypted in an ill-possible way with 5G on top of all the portfolio solutions on top. So I believe, again, A, security, we are all aware of the importance, and B, I think we are prepared both for CSPs as also very customized support for these new use cases for enterprise.
Because of time limit, I think maybe we cannot give more chances to audience. So it's time to conclude. But for concluding remark, you can give some maybe you can give some concluding remark. But in that case, I think we just, as I mentioned first, we just focus on technological issue. But this should go with some social issues, especially inclusive and economic sustainability. So in that sense, how can we harmonize such kind of technological upgrade and some social issues? Actually, not just these, maybe institutional arrangement also important, but Korea's institutional arrangement is different from other European countries. But anyway, so if you consider this kind of differences, but you think there is some spot or some area we can collaborate. So for future collaboration, you can give some concluding remarks. So just you can say something to the audience. First, Sibyl and Professor Jang-Gi-soo and Aman.
Yes, so maybe I can start with the quote. I think it says, strategy without an action is a daydream, and action without a strategy is a chaos. So I think for me, we should start with defining a strategy, meaning that every country, every company needs to have their net zero targets. And again, it doesn't only mean that you have it and you write it in your page, but you need to follow it with actions, and you need to follow it with actions. And I believe countries and all the other institutions around has to enable that. I think we need to mandate this in a way to these rules, and we need to have regulations around how these things are measured so that we don't just throw away the problems in different sites. We need to accelerate the innovation consumption because it's out there. We should not look at the problems in a vertical. There are a lot of solutions that can influence each other. And that requires countries to enable this type of forums to see what things can be done. And again, I think it's more about action, ownership, is about integrity, and it's about all the enablers, different ministers, different regulation bodies, different industries, and the key decision makers to really own it and turn to a clear strategy and clear action.
Yeah, thank you. How about Gil-soo? Yeah, Jang.
지금 우리가 처한 그 전력망의 경우는 신재생 에너지원이 많이 도입되면서 뭐 관성도 줄어들고 강건도도 줄어드는 그러한 전력 계통을 사실은 전 세계가 같이 경험을 하고 있지만 뭐 그것을 완벽히 이해를 해가지고 어떤 생기는 문제를 모두가 다 설명할 수 있는 부분은 아닌 것 같습니다. 아까 우리 아만이 뭐 얘기하신 대로 결국 이제 서로가 협력해가지고 지금 그 문제를 찾아야 되는데 문제를 찾고 해결책을 찾아야 되는데 문제가 발견이 되면 해결책은 찾을 수 있습니다. 그런데 지금 현재 우리가 가보지 않았던 이 전력망 새로운 형태의 전력망 안에서 어떤 문제가 발생할지를 모르고 있는 상태이기 때문에 이제 뭐 그런 것에 따른 불확실성 또는 불안감이 있을 수 있겠지만 이제 그거를 결국은 뭐 현재 기술에서 조금 선진 기업 그리고 또 우리 같이 이제 그 기술을 받아들여서 우리가 전력계통을 운영하고 있는 나라 뭐 이렇게 이제 좀 차이는 있지만 같이 지금 협력해 가지고 그 새로운 이제 불확실성이 있고 겪어보지 못했던 그런 것에서 생기는 문제를 같이 잘 해결해 나가면 좋겠습니다.
How about Aman?
Yes, I think Professor Jung and Dr. Tumbas already answered your question. So I want to use my time to say something else. 100 years ago, if you were basically in Europe, you could not really even think about connecting Germany to UK.
Oh.
So this is the same situation here in East Asia. So I really love the idea of the super grid that Professor Jung introduced, connecting different countries. So we need to be a little bit more open-minded and do not look at this period that we are living in a little bit ahead of time. This is the thing that happened in Europe as well. 400 years ago, we didn't have any electricity. So salt, just salt, was one of the main material that people were fighting against. So today, salt is the cheapest thing that you can see in the market. So this is the thing. We need to think a little bit ahead of time. And then also this U-shaped corridor in Korea is very similar to the other countries like UK. So I would say the way and this kind of perspective of the electrical grid in Korea is brilliant. And then I really urge the government and the policymakers to work on it and do not really close their eyes and say, okay, this is a political problem, we should not really talk about it. So I think this is a correct way forward.
Thank you. Actually, nowadays we say climate crisis. Actually, crisis in Chinese character, it means opportunity with risk. So risk does not come alone. Risk always come with opportunity. So we should utilize the opportunity and not just threatened by risk itself. In that sense, innovation is very important. I really like the idea, innovation. So it's time for us to mobilize our innovation power. Actually, Korea ranked number 5 in the world in terms of a global innovation index. Actually, the highest rank we had was number 4, I think, but it became number 10th last year. But we go 4 grades up. So this year maybe it was announced number 5. So there are big chances for us to realize our power of innovation. So today's topic, the main idea is innovation for our prosperity. Actually, I don't like actually prosperity because it means something big consumption of our resource. But anyway, I think efficiency is very important. So innovative ideas can give us another chances for our prosperity and sustainable future. Yeah, thank you so much. Thank you for your presentation and every comment. Thank you. Thank you.
Very big thank you to our moderator and all the panelists. I just want to say that this year Sweden celebrates 30 years in the European Union. And as was mentioned a little bit by Arman, the foundation of the European Union in a very low trust environment after the Second World War was the integration of coal and steel industries between France and Germany. I really like the vision of Professor Jung's idea about having that integrated grid between the countries here as perhaps a start of something like that. To wrap up our discussion today, I would like to once again welcome Ambassador Carl-Olof Andersson to give some concluding remarks.
distinguished guests, esteemed speakers, and valued partners. As we conclude this inspiring session of the Korea plus Nordic Innovation Days, let us reflect on the depth of collaboration and forward-thinking ideas shared today. Sweden and Korea, bound by a shared commitment to sustainability and technological innovation, continue to pave the way for transformative solution in electrification and energy transition. The discussions we have engaged in today reinforce that progress, and it's truly realized when expertise, creativity, and ambition unite. A special note of gratitude is essential to recognize those who have made this occasion possible. Our sincere thanks go to the Che Institute of Advanced Studies, the Korea Foundation of Advanced Studies, and Korea University's Jean Monnet EU Center, as well as our dedicated Nordic colleagues, whose contribution have been instrumental in shaping this dialogue. Above all, let me extend our deepest appreciation to the distinguished guest speakers today. Dr. Arman Hassanpour of Hitachi Energy, Korea, Dr. Sibyl Tombes of Ericsson, Korea, Professor Gil-so Yang of Korea University, and Professor Sun Jin-yoon of Energy Transition Forum and Seoul National University. You have generously shared your expertise and insights with us today. Your contributions enrich our collective vision and propel us towards a meaningful impact. This event does actually not mark an ending, but rather a new beginning. As we move forward, may the partnership forged today flourish, and may the ideas explored lead to practical, lasting change. I also encourage you to continue the journey of innovation at the Nordic Playground for Happiness at Seoul's Plaza's Outdoor Library this weekend, an opportunity to immerse in the Nordic sentiment alongside our colleagues from Finland, Norway, and Denmark. Thank you once again for your presence, your engagement, and your dedication to shaping a cleaner, greener, and smarter future. Wishing you all a wonderful evening, and I look forward to seeing many of you again. So thank you so much, everyone.